reaction rate and temperature change in hydrochloric acid. In my experiment, I added 0.03 grams of magnesium to 2 milliliters of hydrochloric acid. The hydrochloric acid was heated and cooled to different temperatures. I observed how the increasing temperature affected the reaction rate by recording how long it took for the magnesium strip to react completely with the hydrochloric acid. The chemical concepts illustrated by this demonstration are temperature, kinetic energy, activation energy, colliding particles, Arrhenius equation, and reaction rate. Kinetic energy is energy of motion. As the temperature increases, so does the kinetic energy. Looking at the graph, you can tell solutions with higher temperatures and kinetic energies have more particles that are able to reach the activation energy. The highlighted section represents the number of particles with enough energy to react. The red line, representing the higher temperature and higher kinetic energy, has the most particles. Increasing the kinetic energy also increases the speed of the particles in the solution. With particles moving faster, the percentage of successful collisions increases over the same amount of time. As the percentage of successful collisions increases, so does the rate. Activation energy is the minimum amount of energy needed for a reaction to occur. Change in temperature and change in kinetic energy do not change the activation energy. However, with an increase in temperature and increase in kinetic energy, there's an increase in particles with enough energy to overcome the activation energy, causing the reaction to increase its rate. The Arrhenius equation proves that with an increase in temperature, there's also an increase in rate. Following the steps below, you can see that with the increase in temperature, it leads to an increase in rate. My data shows that with an increase in temperature, the length of magnesium reacting completely in hydrochloric acid decreases. The temperature of hydrochloric acid increases around 10 degrees Celsius each time. The rate just about doubles each time. Looking at the reaction rate for each temperature, you can see as the temperature increases, the reaction rate increases as well. My data proves that with an increase in temperature and increase in kinetic energy, enough particles can overcome the activation energy, increasing the reaction rate. So if you ever need a reaction to occur more quickly, try increasing the temperature.